All right, guys, we're moving on to a little bit different topic. You may be thinking to yourself, what in the world does this have to do with the Pythagorean theorem or what we're going to be doing? But what I figured out over the years here, trying to teach this subject, is this is something that students really have difficulty with. And so I've learned to kind of take a lesson or two and try to teach this just a little bit before we just throw you in. Actually, your book, it just kind of dives in right straight into this and doesn't really give you any kind of background. And so, again, we've learned kind of over the years that we need to take the time to kind of go over this. So, what we're going to be talking about today is simplifying radicals. Okay, so a radical is basically a fancy word for square root. Now, once you get into algebra 2, you're going to get into things that are cube roots and fourth roots, that kind of thing. With geometry, you're not going to be, but this will definitely help you when you get into that higher level math to be able to do this. And so you're going to have to do this again. This is not going to go away. And actually, I left a few sections out of this chapter that I would usually go into, but just because of the way everything's going and us having to learn virtually and some different things, I just left it out this year. But again, this is something that we really need to learn how to do. And so I want to work through about 4 examples here. And these, if you will really pay attention, you will figure out that a few of these examples, as a matter of fact, 3 of these examples are actually on your practice. And so if you miss these 3 on your practice, I'm really going to have some issues. Um, but basically, what we're trying to do is we're trying to get these into simplest radical form. And so if you notice here, I've got the square root of 50. So one of the first things you need to do, and I would encourage you to do this on a separate note page or something, and keep this with you. This is going to be something again that we're going to add to in algebra 2 anyway. So it'd be a good note to just have on hand. But one of the first things you need to do is create an x squared table. I'm going to show you what I mean. So I'm going to go ahead and make me a little table here. And on this side, I'm going to go ahead and put x. Here, I'm going to put x squared. So this is going to be real simple. I'm just going to number this 1 through 12. It's probably a good start. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And what we're going to be doing here is we're just saying, okay, if I take x, which is in this case is 1, and I square it, what number do I get? And this is really going to be helpful when we start talking about square roots. So 1 squared is very simply just 1. Okay. If I take 2 squared, then that means I'm taking 2 times 2, which is the equivalent of 4. All right. If I take 3 squared, well, it would be the same thing as 3 times 3, which actually equals 9. And you can kind of get the idea of what we're doing here. We're just taking this number times itself and figuring out what this really is. So 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. And I'm just kind of doing these real quickly, but you could check them on the calculator and make sure they're correct. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. And that's probably enough for now. I've actually seen students that go all the way to 30 with this. You can if you want to. It doesn't really matter, but this will probably be sufficient for just about anything that you're going to be doing. So basically what we're doing here, these again are perfect squares. So let's think about this for just a minute. If I look at the square root of 4, for example, then that equals 2 because 2 times 2 equals 4. So you notice this kind of goes both ways. 4 is 2 squared, but 2 is also the square root of 4. So you can see how that kind of helps me both directions. So if we're looking at the square root of 50, you notice 50 is not on this list at all. Okay? So that means the 50 is not a perfect square, whereas 4 is a perfect square. The reason it's perfect is because it comes out to exactly a whole number. Okay? So if I look at the square root of 25, for example, that is a perfect square because the square root of 25 is 5. So it comes out to a whole number. Well, in this case, this one is not going to come out to a whole number because I don't have a whole number over here that's represented. So what I have to do for this example, the square root of 50, is I have to look at my list. And there's no use to look at 64 or 81 because those numbers are all bigger than the number I'm even dealing with. So I'm going to start right about here, and I'm just going to put me a little dotted line for now. And I'm going to look back through these numbers, and I want to encourage you to start with the biggest number that you have, okay? So I'm going to start with 49. 49 won't go into 50. So what I'm looking for numbers that may help me to simplify this number. And so I'm looking at these perfect squares that are over here. 49 won't go into 50, obviously. 36 won't go into 50 evenly, so that's not really going to help me. But notice the next number that I come to. The next number that I come to on my list, and I'm looking up through this list right here, right, my x squared list. The next number I come to is 25. 25 will, in fact, go into 50. So watch what I'm going to do. I'm going to rewrite this. Instead of the square root of 50, I'm going to rewrite this as 25 times 2. Now think about that just a minute. I didn't do anything magical there or unruly. I'm still well within math rules, because if I take 25 times 2, I'm going to end up with 50. This is really the equivalent of the same thing. I've not really did any kind of magic or voodoo. I've just basically just made this into two numbers, okay? Now watch what happens. I'm going to take one more step with this. I'm going to go ahead and say the square root of 25 times the square root of 2. Now again, if I multiply these out, I'm still going to end up with the square root of 50. So I've not did anything except just rewrite it a different way. This is equivalent to that. This is equivalent to that as well. If you put all these numbers in the calculator, just like the way I've wrote them out, you're going to come up with the same exact numerical answer. But what we're looking for is this to be in simplest radical form. So now let's look at what happens here. Notice this, the square root of 25, is a perfect square. So what is the square root of 25? Well, if you've been doing a little bit of this math already, the square root of 25 is 5. So this simplifies to simply 5. Well, what about the square root of 2? Can that be simplified anymore? Well, if I look back through my list, the next smallest number is 1, and that's not really going to help me at all. It's not going to help me simplify. So here's what I'm left with for an answer, is 5 times radical 2. Now, you'll remember if I have, for example, 2 times x, well, what's another way I can write that? Well, I can simply just write that as 2x, because it's understood that there's multiplication in between here. So guess what? You can do the same thing here. You can just squeeze that 5 right in beside of that 2 like that, and that means the same thing as that. Now, what's going to be really crazy right now is if you take your calculator and you do the square root of 50, okay? The square root of 50, I'm going to go ahead and do that on my calculator as well right now. If I do the square root of 50, I get that big, huge number, 7.07. We'll round it to the hundredths place, right? So 7.07. It's approximately that, okay? Now watch what happens when I take that same thing and do 5 radical 2. Remember, this was the other answer that we got right here, 5 radical 2. So I'm going to put that same thing in the calculator. Watch what happens. 5 times 2 radical equals, look what happens, 7.07, exactly the same number. And so these are equivalent to one another, but this is this answer in simplest radical form. Okay, so this would actually be your answer that you're looking for. Again, this is a very difficult subject to try to kind of get into, but it's something that's necessary that we need to look at. So let's look at another one. Let's look at the square root of 48. Okay, so the first thing I'm going to do, since I've made this table, I've already did the work, is I'm going to look through this x squared column, and I'm going to see if this number 48 shows up. Well, it doesn't. 49 is really, really close, okay, but it's not. So I'm going to be looking at any numbers that are above that. So just by looking at 48, what number do you know will go into that? Well, if you look, you see this 4, right? So let's think about that. Well, 4 go into 48. Well, we could take our calculator. We could do that calculation. 48 divided by 4. Well, that's going to come out to 12, okay? So I could rewrite this as 4 times 12. So again, all we did was the same thing we did up here. We just rewrote this. Instead of writing the square root of 50, we rewrote it as 25 times 2. Well, I'm doing the same thing here. Instead of the square root of 48, I'm rewriting it as square root of 4 times 12. Well, what happens here is now I can rewrite it again as square root of 4 times the square root of 12. And then I've got square root of 4 is 2. So that just becomes a regular O2. But now I've got times the square root of 12. Now my question to you is this. Is there another perfect square that can be pulled out of this 12? Well, as a matter of fact, there is. If I go back through my list, look here, here's a number 4 again. 4 will also go into 12. So now I'm going to have to rewrite this again. This is getting aggravating already. 4 times 3, I can rewrite 4 times 3 as being 12. And now the square root of 4. Now remember, there's multiplication between all this stuff, right? So now I've got 2 times the square root of 4 times the square root of 3. And now I've got 2 times the square root of 4. Well, square root of 4 is 2. 2 times 2 times square root of 3, which equals 2 times 2 is 4. And the square root of 3 we can't really do anything with, right? Because we look at our list. Now that's a whole lot of work. But I could have actually saved myself a whole lot of work. Watch this. So let's start with square root of 48. And remember I said you always want to find the biggest number that will go into these. And here's why. So 36 won't go into 48 evenly. 25 won't go into 48 evenly. But 16 may in fact go into 48 evenly. And if you do the math, if you do 48 divided by 16, you actually get that it is 3. So we could have rewrote this as 16 times 3. Then we could have split it out just like we did a minute ago. The square root of 16 times the square root of 3. And then the square root of 16 is 4 and radical 3. Look here, I've already got to my answer in just 2 steps instead of having to go through all those steps. So that's why I said it's vitally important to make sure that you go through this process and look for the highest number that you can possibly find. Okay? All right, 2 more examples real quick. So here we have what I'm calling number 3, and now we have the square root of 3 times the square root of 15. Okay? So let's go back to our list real quick, and let's see if we see either one of those numbers in this list right here. And you'll note that you do not see either the 3 or the 15 in this list at all, right? So that means both of these are not perfect squares. But you notice I've got a multiplication right here. Now, what did we say up here? This is the same thing as that. So we took 48 and divided it into 4 times 12. Well, I can work that the other way as well. I could take the square root of 3 times the square root of 15. So 3 times 15 is actually 45. And now maybe the square root of 45, maybe I could find a perfect square out of that. I couldn't find a perfect square out of each of these individually, but maybe I can find a perfect square out of this. So let's look through our list real quick, and let's see if we see anything that would go into 45 evenly. Okay, again, we're always looking at our x squared list. So there's no use to look at 49 because that's too big. 36 won't go into 45 evenly. 25 won't go into 45 evenly. 16 won't go into 45 evenly. What if I take 45 divided by 9? Will 9 go into 45 evenly? Well, as a matter of fact, it will. So watch what happens. We're going to rewrite this as the square root of 9 times what? 9 times what gives me 45? Well, that's 5. So now I could rewrite that as the square root of 9 times the square root of 5. And the square root of 9 is 3, all right, according to our table. And I just simply have the square root of 5 that goes along with it. So there is my answer to this particular question. Last but certainly not least, we've got one more. Again, I know this is going to be challenging. It's very challenging for me to try to teach this this way. Hopefully we'll get back to in person real soon and be able to really take a look at this stuff. If you need additional help, you can obviously always contact us and try to get some help. So let's look at these two again, and we're looking for perfect squares. Okay, so let's see if we see any perfect squares in these two. and you see a 6 here. I'm going to go back to my list real quick, and I don't see anything that would go into a 6. A 4 won't go into a 6 evenly, and a 1 would, but it wouldn't help us at all. And I've also got the square root of 8. So let's think about the square root of 8. Is there a number up here that would go into 8 evenly? Well, 4 would go into 8 evenly, right? So we could rewrite this one as the square root of 4 times the square root of 2. We're just going to bring our other work down. Then here we've got the square root of 4 times the square root of 2. Again, I'm just rewriting these exactly like I did up here before. Times negative 2 square root of 6. Now I could take the square root of 4, which is 2. So I really have 2 radical 2 times negative 2 square root of 6. Now let's think about what really happens here and what we can do. Okay? And what happens here is I'm actually going to multiply. You notice I've got a number here and I've got a number here. I'm going to multiply those two numbers together. So 2 times negative 2 is negative 4. Then I've got square root of 2 times square root of 6. Well, that 2 times 6 is going to be 12. So I'm going to end up with the square root of 12 like that. Okay? So now let's think about what happens. This is the last step, by the way. Is there a perfect square that'll go into the square root of 12? If we go back into our list again, and again, that's why this list is so vitally important. If we go back into our list again, we'll see that 4 goes into 12. And we kind of already seen that in another one of these problems, right? So I could rewrite this one more time as negative 4 times the square root of 4 times 3, or negative 4 times the square root of 4 times the square root of 3. One last step is the square root of 4 equals 2. So really I have negative 4 times 2 times the square root of 3. And this would end up giving me a final answer of negative 8 square root of 3. Again, I know this is kind of long. It's kind of arduous. There are 3 of these problems that are actually on your practice that you're going to have. I'll go ahead and show you what that looks like. There are 20 problems total. Do the best you can, and we will give you as much help as we possibly can. If you need help, just contact us so that we know that you need help. We don't know unless you ask, okay? But look through that perfect squares list. Make sure that you make you a perfect square table just like this one right here. If you want to continue that on to say 20, you can do that. It doesn't matter. But use this table right here to try to help you to figure out how to simplify these radical terms. If you need help, reach out to us. Thanks.